All right, before we start this review, the main thing that I want to point out to you is that it is really, 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 really important that you can tell the difference between problems that are proportions and problems that are means. Because problems that are proportions will use different formulas and different test statistics and use inverse norm and norm CDF. So let's take a look at this review here to differentiate between proportions and means. So remember here that on the critical value for a Z star, so that's like if they say I want to be 95% confident, then you're going to put 95% in the middle and inverse norm one tail, your Z star. But if it's a mean problem, and remember that with a mean problem, what's happening is the reason you would use T's instead of Z's is because you only have the samples standard deviation. Okay, you are using the samples standard deviation as an estimate, not the population standard deviation. So we're using means if we only have the samples standard deviation, not the population one. Okay, so we have more variability. So we have this T star. These T curves would be for a critical value. If I say be 95% confident, then I would want the critical value. Do inverse T of one tail, but comma, you have to tell it what degrees of freedom to use. And then remember your DF is your N minus 1. Okay, now on the formula chart, we have got these different formulas. We've got this standard deviation here for proportion problems. You find the standard deviation with the proportion. But for mean problems, they'll give you the standard deviation, okay? So, and then also, let's take a look at this on our formula chart here. So we can see this is the formula chart, and here is the proportion section on the top half, and here's the mean section on the bottom half. And I want to point out to you how to do these two proportion and two means, because sometimes we'll see those. We use our calculator most of the time, but sometimes those will appear as a multiple choice question in a form that we have to recognize this formula for two independent proportions. Okay, now notice this is called standard error. Why would it be called standard error instead of standard deviation? Because it is made with the sample standard deviation instead of the population's standard deviation. Okay, so standard error made with the sample's proportion instead of the population proportion. All right, same thing with the means. If you know the population standard deviation, you're using sigma. If you do not, and you're using the sample standard deviation, then you're making a standard error. Okay? And here's those formulas here. All right. So those are on your formula chart, and you need to be able to find those. Now, back to this. Okay? So let's talk about if you have to get your Z-score. So if you're on a curve and you want to find where your sample is, where your p-hat minus the mean, how far is your sample away from where it's claimed to be in terms of standard deviation? Same thing is happening over here for a t-score. This is your test statistic for the t. Sample means, see how far your sample is away from where it's supposed to be centered in terms of that standard deviation. All right, then once you get these test statistics, that z-score or that t-score, then you norm CDF to get your p-value. So I can write these things in here. So if you're going to be getting your test statistic, that's your t-score or your z-score, and then you would get your p-value to get that area. Okay, now, one word of warning. Please remember that if you have an HA that is two-tailed, so meaning HA is a not equal to symbol, then once you get the p-value of one tail, you multiply it by 2 to get the p-value for two tails. Okay, so you need to watch that because I know that will happen to you. Now, if you do the computing in the calculator and you do the not equal to symbol in the calculator, that will automatically calculate two tails for you. So for example, if we were to go run a test here and then we had this two-tailed not equal to, that automatically does the two combined tails for the total p-value for you. All right, and then here is your confidence interval. So if we have, so I'm going to write that in a confidence interval. So confidence intervals for proportions and for means. And so here is that formula that you have for that. So keep in mind if HA is two-tailed. So here's the confidence interval formula. This is on the formula chart. It is located, let's see, I think it's on the bottom of the front. Let's take a look. Yes, here it is. It says that the confidence interval is that statistic plus or minus the critical value times that standard error. Okay. And then you can see what I'm pointing to in terms of the standard deviations or the proportion problems that you plug in, what you plug in for those, and the mean problems, what you are plugging in for those. Okay, so that's your overall review. Now let's go to the review. Oh, I forgot about this. Your errors. Okay, you have your, remember what I have shaded here in purple are the mechanisms that a researcher has control of. So keep in mind with that, because I noticed on the recent quiz we had, some people wanted to say that if they change n, that will change the probability of type 1 error. And type 1 error actually won't change unless you change alpha, because you, as the researcher, control alpha. The only way you can control or change that type 1 error is if you change alpha, okay? And so then there's those things, and these are ways to change the power, and then down here are the ways that we can increase or decrease power and how those arrows go. Okay, so here we go to the review. Okay, so this first one, this was the only free response I gave you, unless you were a AP tester. There's one at the end. This was from 2018. And so the first problem actually just asked you about, it was an observational study or an experimental design problem. And so with this problem, when you read this, yes, the design of this study is an experiment with two treatment groups, the standard procedure and the new procedure. But the reason that you can conclude cause and effect is because the subjects were randomly assigned to the treatments. So that's what you had to say to get credit for that part there, that the subjects were randomly assigned to the treatment groups. This spreads unknown traits evenly so that you can then, so that the effect can be attributed to the treatment. All right, then we were asked to actually see if we have statistical evidence. And anytime you are asked to find statistical evidence, that means you need to run a hypothesis test and get your p-value to compare to alpha, and so on and so forth. So this has two different, so I'm going to do a phantoms. So the parameters, there are two different ones. This was two independent means, two independent samples. So mu of S was the average recovery time from the standard procedure surgery for all such patients, and mu of N was the average recovery time from the new procedure surgery for all such patients. The null hypothesis is that the average recovery times are equal, and then they were wondering if the new is less than the standard. Now, pay attention to how you do this sign here, because if you're going to put standard in first into the calculator and new in second, then I recommend you write that with the standard first and the new second, so that this symbol is like what you pull up here on the calculator down here. See, so we'll be pulling up this symbol here where we want mu1 to be greater than, right there, mu2. Okay? So you have to make sure you pay attention to that. All right. So our random, we had stated 110 patients were randomly assigned to the standard procedure, and it was stated that 100 patients were randomly assigned to the new procedure. Now, for our independent, I have both of these n is less than 10% of their respective populations, and it's also critical that you state that the patients in the two procedure groups are independent of each other. Now, I recently, I'm always learning, have come to learn that this 10% condition is only needed for random selection from the population. So if I just am doing an observational study and I randomly select, but not with random assignment with an experiment, okay? Because this is kind of strange saying, 110 is less than 10% of all such patients that ever go on the standard procedure. It's kind of strange. So I've learned that for the random assignment, we actually do not show the 10% condition, only for the observational studies where we have random selection from the population. So I do not want that to just blow your mind and throw you over the wall. I will not count off for that, and rarely do they count off for that in AP. Only occasionally has it shown up as one where they counted off for that, and teachers have had to dig far and wide to find the ones where they actually took off for that. But that doesn't happen very often. So for our large enough, they were both greater than or equal to 30, so the approximately normal model applies. To sample t-test for means. So I went and put this into my calculator with the standard procedure information in first, the new procedure information in second, and then remember that we never pool. So our two sample t-test results are this. Now, look at this p-value. There is no such thing as an 836% chance of finding this sample or something more extreme. Don't forget to look at the end. And do not write e to the negative 12. This is 8.36 times 10 to the negative 12. Make sure you write the degrees of freedom. The p-value, which is basically 0, is less than alpha. So that since that p-value is low, I'm going to reject HO. So there is evidence that the recovery time for all such patients who receive the new procedure will be less on average. You either needed to say the average recovery time for all such patients or less on average. But that on average has to be there because that's an overall average, not individual amounts than those who receive the standard procedure. What I actually did here is I actually worded it just like they had here. Is this statistical evidence that those who receive, see, I just used this exact wording when I did my conclusion. Okay, so there you go. All right, that is the free response. And so because we get some kind of introductory review and then free response, I'm going to go ahead and stop right here before we start into the multiple choice problems.